All right, ladies and gentlemen, you all should have this note sheet out in front of you. Please make sure, if you did not in the middle of class, go down here and in our alternate interior angles under proving congruent angles, make sure you just cross off these congruent angles. They should not be on there. Okay, let's get started with this. We're going to prove congruent sides. These are just our reasonings when we're writing our E of our PEA. These are going to be our reasons. So given, when we see congruent markings on the side length of our triangle, we can say two side lengths are congruent. So by this, I can say side length AB is congruent to side length DE. So I'm going to get one of my three colors. You should have three colors out doing this, and highlight this side. AB is congruent to DE. That is these side lengths. And we know that these are congruent by given. Another one I can write down is CA is congruent, and that's your lunch bell. CA is congruent to DF. Yep, FD. FD. CA is congruent to FD by given. And in a new color, CA, FD, now it's this one. And your next one and your last one is CB is congruent to, sorry, I'm writing on the edge. CB is congruent to FE by given. And take your last color, trace it out. CB is congruent to FE by given. So that's what our reasoning is for given. That's how we can identify what side lengths are congruent by given. Let's go to our reflexive property. When two side lengths sit directly on the top of each other, we know that they're congruent by reflexive property. So I know that BD would be congruent to BD as well, because if my triangle is ABD is congruent to triangle CBD, I know BD would be congruent to itself by BD. BD is congruent to BD by the reflexive property. So I'm going to take my color, mark it up so I know what I'm talking about. All right, my next one, there's no other reflexive sides on here, so I go to this next guy. If this is my triangle, PRQ is my triangle, and SQR is my other triangle. Here's my reflexive side. So RQ is congruent to RQR. RQ is congruent to QR by the reflexive property. Marking this guy. Just so that you have something to see. All right, those are my reflexive properties. Let's now go down to definition of midpoint. Definition of midpoint, we know this from the beginning of the unit. We know that the definition of midpoint is when a point in a midpoint of a line segment, when a point is a midpoint of a line segment, I apologize, please copy that down onto your note sheet. When a point is a midpoint of a line segment, it cuts the line segment in half, resulting in two congruent sides. So if D is a midpoint of AC, that means this guy is congruent to this guy. So that would tell me AD is congruent to DC. This is by the definition of midpoint. So if I color code this, AD is congruent to CD by the definition of midpoint. And there's nothing else that we can do after we know that that was our midpoint. So this next one, N is the midpoint of MP. N is a midpoint, which tells me these two sides are congruent. So MN is congruent to PN. And again, this is by definition of midpoint. So if I color code this one, this side is congruent to this side. And there we go. You may be wondering why I'm color coding. You will understand why we're color coding when you come to class tomorrow. We're going to prove triangles are congruent by color coding. So essentially you will have 3 different colors when we're proving it. So that's the definition of midpoint. Definition of line segment bisector. When a line segment bisects another line segment, the line segment is cut into 2 congruent parts, resulting in 2 congruent sides. So if BD is my segment bisector of AC, that means this guy cut AC in half, resulting in AD being congruent to CD. And this is by the definition of line segment bisector. So that tells me AD is congruent to CD. Awesome. So that's proving congruent sides. Let's now go down to proving congruent angles. Given. So when we see congruent markings on the angles of our triangle, we can say that they are congruent by given. So we can say angle B is congruent to angle E by given. If you want to write it in the proper notation, you could say angle CBA is congruent to angle FED. And let's color that one green. So let's say angle B is congruent to angle E by given. And let's do another one. Let's say angle A is congruent to, this one has 2 markings. So angle A is congruent to angle D by given. So angle A is congruent to angle D by given. Remember, the only reason we're able to use one letter for these guys is because these 2 triangles are not touching. If my 2 triangles were touching, I would have to use proper 3-letter notation. My last one, angle C is congruent to angle F. I have 3 markings here and 3 markings here, so they're congruent. And that's by given as well. Let's make that one my orange. Okay, that was given. Now definition of perpendicular. When 2 segments are perpendicular to each other, they form right angles. So if we know that AB is perpendicular to PA, it's going to form a right angle. Sometimes they're not going to be shown for you. If we know that CD is perpendicular to PD, it's going to show a right angle. So we can write this down by knowing angle BAP and angle CDP are right angles in the definition of a perpendicular. Okay, that's my reasoning. Color coding these, that's saying this angle and this angle are right angles. Moving on to down here, if I know that BD is perpendicular to AC, that tells me this angle and this angle are perpendicular. So it says angle ADB, and angle CDB are right angles. Are right angles, and that's by the definition of perpendicular. Color coding this one, I'm going to get this angle and this angle are right angles. All right, moving on to alternate interior angles. Again, this is the one that you should have crossed off. These angles should not be here. I made a mistake when I was printing them. I don't want them to confuse you, so please cross those angles off. We did a lot of these in class, so you should be familiar with these. When you have parallel sides cut by transversal, alternate interior angles are formed. So if I know that these 2 triangles, they mean parallel, I'm always going to draw my parallel lines and my transversal that cuts it. So I have now formed a Z. The only angles that are formed with this Z is this angle and this angle. Okay, so these 2 angles are the angles that are congruent. So we could say angle EGO is congruent to angle MOG. EGO is congruent to MOG, And my reasoning is alternate interior angles because we knew that we had congruent parallel sides. Not congruent sides, I apologize, just parallel sides. All right, so that's my alternate interior angles. Let's move on to right angles. When we have two triangles have right angles, my reasoning is just that we have right angles. All right, so if I have two right angles here, I can say that angle BAP and angle CDP are right angles, and this is by the definition of right angles, or by given, I would take either. The reason why I want to talk about this is what does it mean to have right angles? It means that we have right triangles. So then we would be able to say triangle BAP and triangle CDP are right triangles, and this is by the definition of right angles. All right, we knew that these were our right angles, which gives me these guys to give me my reasoning of my right triangles. Vertical angles. Again, throw back to Unit 1. When two angles are touching at the vertex, we're considering N our vertex, even though there are others. When two angles are touching at the vertex, we have vertical angles. So this angle is congruent to this angle by vertical angles. So we would say angle MNL is congruent to angle MNL is congruent to angle PNO by vertical angles. So this guy and this guy give me that one. Definition of bisector, our last one. When a line bisects an angle, it cuts the angle in half, resulting in two congruent angles. So if side length BD is an angle bisector of ABC, that cuts these two into two congruent angles, meaning angle ABD is congruent to angle CBD by definition of angle bisector. All right, so make sure you get all that written down. Make sure you had that all highlighted and color-coded as well, because we will be doing the backside in class, and we will be using this as often as we can using our proofs. I will scan out so that you can pause the video on anything that you may have missed. And let me see. I don't know. We'll figure it out. Maybe this will be cropped out. It's not cropped out. Then you got to just enjoy my commentary of trying to do this. Yay! We'll figure it out. If you've got this, you can stop watching it. But if you don't, then make sure you do it. Rotate. I don't know which way we want to go. Oh. No. Yay! All right. So make sure you get these all copied down. We're just going to crop this part off because you can't even see it all. So never mind. Okay. Can we stop? Oh,